Differential Calculus 2014, question 10a. A particle moving in a straight line experiences a retardation, some acceleration. It's slowing down, so we're looking at minus a of 0.7 v cubed ms to the minus 2, where vms to the minus 1 is its speed. It takes 0.04 seconds to reduce its speed from an initial value of 200 to v1. So we know we're going to be looking at integration here, 200 initially up to v1. And my t value is 0.04, so my t value is going to be 0.04 and start at 0. So find the value of v1. Okay, so we're looking at acceleration. V is equal to u plus at. So we're dealing with v and a here, or v and t. dv dt is equal to a. So if we look at my retardation, so I'm going to call it minus 0.7 v cubed, that's going to be equal to dv dt. So I want t on its own and v on its own, so if I move the v cubed underneath the dv, so I'm going to get dv over v cubed. I might bring the minus across there as well, I might put the minus in here, is equal to 0.7 dt. So if I put my integration bands in, I'm going to integrate this. I've got my minus in front. We said v1 is what we're looking for, 200, and between 0.04 and 0. So integrating, it's going to be v, or 1 over v cubed, or v to the power of minus 3. So we're increasing the power, divide by the new power. So we're going to increase the power to minus 2 and divide by that minus 2. And I've got a minus in front, so that's going to give me that minus there. It's going to give me, bring the v back down to the bottom, it's going to be 2v squared down the bottom, so 1 over 2v squared. So that's what I get here, 1 over 2v squared between v1, 200, is going to be equal to 0.7t between 0.04 and 0. So that will get us to 1 over 2v1 squared minus 1 over 2 times 200 squared is equal to 0.7 by 0.04, and the 0 will just be a 0. So we simplify this down. We're going to get 1 over 2v squared, or 2v1 squared. But this number here is so small, 1 over 2 times 200 squared is going to be a tiny number. So we'll just end up at 0.7 by 0.04, 0.028. So 2v1 squared is equal to 1 over 0.028. And if I divide that whole thing by 2 and get the square root of it, I'm going to get my v1. So v1 is equal to 4.23 decimals 225 ms to the minus 1. So that's v1. Part 2, the distance traveled in this 0.04 seconds. Well, distance is s, so within this integration we need the s. What do we have? We have acceleration, which is dv dt. We also have velocity, which is the s dt. So how am I going to get back here? So my dv dt, if that's my acceleration, how do I get something equal to acceleration with my variables here? I have the s dt. What do I have to multiply that by to get dv dt? I'd have to multiply it by dv ds. This is where my s is going to come in. So the s dt is velocity by dv ds is going to give me my acceleration of dv dt. So my velocity by dv ds is equal to my retardation, which was minus 0.7 v cubed. So divide by v to get dv ds is equal to minus 0.7 v squared. So now I want my s on its own. So I'm going to have dv, not vd, dv over v squared is equal to minus 0.7 ds. And if we integrate these between, well, it's going to be between s and 0. And what answer did we get for part 1? This 4.255 was my v1. So you can see that's going to be on top and my 200 on the bottom. So between initially 200 down to 4.22. So if I get integrate v to the power of minus 2 or v squared, I'm going to get v to the power of minus 1 over minus 1, which is minus 1 over v. So minus 1 over v between 4.22 and 200 is equal to minus 0.7 s. I can multiply across by minus 1. So I'm going to have 1 over 4.22 minus 1 over 200 is equal to 0.7 s. So if I just type this into a calculator and divide by 0.7, 1 over 4.22 minus 1 over 200 divided by 0.7, I'm going to get 0.331 to 3 decimal places, and that will be in meters.